What's up, YouTuber? Let's talk about data modeling. So data modeling is the process of using business logic to aggregate over event-driven data. This is sort of a new definition. As you can see, aggregate over event-driven data, which means everything that happened in the business, whether somebody registering to join or a newsletter or a customer buying item X or Y, is now considered an event-driven data. So with data modeling, we use the business logic. The business logic may also include, a customer buying something, it's a business logic, or a customer registering to join the newsletter. So we aggregate over event-driven data to produce structured data and achieve business objective. As you can notice here, instead of using business requirements, I'm using the business objectives, which means the business objective is more coming from the executives instead of coming from the technical side, where we use the business requirements for operations. So what are we now talking about this video? This video is not about the object-oriented data modeling, which is a subject to software design. We are now talking about mathematical modeling. As you can see, I underline mathematical modeling with green. As much as I love mathematical modeling, but we are not going to talk about that. We're not talking about schematic modeling either. Data modeling, it's not about schematic modeling, which is a subject, specific to field like civil engineering or electrical engineering or mechanical engineering. We should have been talking about data normalization, which is a subject included in data modeling in computing, but we're not going to talk about data normalization in this video. As you can see, it's underlined with blue, and we have a statement inclusive but not covered. We're not going to talk about database normalization. Business objective. So I will start by explaining how the data can be modeled quickly using the relational database management system. The majority of business now use relational database instead of using the NoSQL database. But before we even model our data, we need to go from the business objective. For our business objective, we have in the last 3 months, the number of newly created accounts has been decreased by 2%. We want to give 2% to our new customers who deposit a minimum of $1,500. The campaign should start from date X, date Y. Now, this is where everything makes sense as a business objective here. So that determine a business objective, so that we can incentivize more account creation and increase the rates by 10%. By 10% to also be specified on time and space, maybe by 10% in 2 weeks or 10% in 6 months. Okay, that's our business objective from which we're gonna model our data from the conceptual data to the physical data. Next, so the first thing we need to do is we need to identify conceptual data. The conceptual data, as the word suggests, concepts are just key concepts from the problem. And if we read the business objective, we can see the main concept that we are dealing here are customers. We have an account. We also have a campaign, so we need to model a campaign. We need to model a customer. We also need to model accounts. And the assumption here, we are dealing with a commercial bank. I'll say it again. The assumption here, we are dealing with a commercial bank, just to avoid confusion and triggers. Okay? After identifying our conceptual data, we need to create the logical data model. The logical data model consists of defining attributes of conceptual data and the relationship between them. As you can see, we have accounts. Now, accounts is defined, and we have attribute for accounts, account type, balance, And we also have a customer. So one customer can have one or multiple accounts. Okay, that's our logical data model. And last but not least, we have the physical data model. The physical data model represents the relational objects. We have tables, we have indexes, we have constraints, and we're not gonna cover about what are indices. When should you use index and when you should not use index. So constraints, sequence, schema, and so forth. Those are physical data model that represents the conceptual or the logical data onto a relational database management system. Let's go to the demo and demonstrate how we can use the famous Django model to create our model and lastly solve this problem, which consists of giving 2% to whichever creates a new account in this bank X, give them some 2% more to their balance. I'll see you in the demo. Okay, now that we've introduced data modeling, we are set that why we should consider modeling data, even if we are using an agile methodology to deliver features while creating or developing applications. Let's create our physical model as table using Django model. To do so, we already have a customer or application here, but for the sake of this demonstration, we want to create a new app. We will call the application banking, Python manage start up banking. We should have our new banking folder here. Django has automatically creates admin file for us, the app, and the famous models.py. So we need to start creating the definition of our logic models. So let's start with the customer. Since in our problem we are asked to automatically add 2% to every new customer who creates the accounts with a minimum deposit of 1,500. So the parent's entity in this case is the customer entity. So we start by creating a model called customer. Model user model, that will be the customer. So we want to create a one-to-one relationship with the user who will be the customer, which means we cannot have a customer without a user. So if the user is deleted, automatically the customer is deleted as well. So let's create a foreign key. We got user and user. We need to import from Django contrib auth model import user. So we import our user on delete model cascade, which means when a user is deleted, the customer will be automatically deleted as well. And this depends on the business rules. if the business rule stipulates that we shouldn't delete customer even if a user doesn't exist, we should keep customer records for a bunch of reasons. We should, instead of doing cascade, we can set that to null. Set that to null, which means even if a user doesn't exist, we still have a customer record relating to a particular user. So that was a constraint, but let's bring that to cascade. Next, we need the address of our user. Address 1, which is usually the line 1, models, char fields. The maximum length for this address should be, let's say, 50 characters. Null should be false. Null false. Blank should be true. The difference between null and blank is that blank is applicable to every Django forms, either using Django forms or using Django admins. So when you set blank, it instructs the Django admin to require a value. If blank is true, which means it may be empty. Null is on the database. If null is set to false, it means we should have a value. So since null is false, blank should also be blank should be true. No, blank should be false. Okay, so in every Django form, we should be inserting the address line 1, address 2, model char field, max length. Let's make this one 25 characters. Null should be true, which means the user doesn't have to insert a value in this second address. Blank should also be true as relates to Django form. Next, we have the country of our customer, models, char fields, max length. Let's make that 80. Blank false. Null false. Blank false. And if a country must have a value, it should also be deducted from the business rule, not the business logic. As far as the business logic, we know that a customer should belong to a specific country, but as far as the business rules, it's up to us to insert the customer country or just avoid, make that optional. The states or province, we can make a model char fields, max length to 50, null false, blank false. Next, we have the phone number. First, we need to add one constraint on the address. We want to make sure that our address will not have something like gibberish, some special character. So to do so, we need to validate our address. We can pass validators, which takes in a list of class-based validators or function validators. So let's create our validator for this address. We want to make sure that our address should be something like a 123 long streets, something like this. Okay, so to do that, we can create a new file. Let's call that shared .py. We can add so we can track that. So we can import the regular expression module from Python, also from Django call exception. We import the validation error, which throw the error if the requirements for this field is now satisfied or is now matched. Okay, let's create our function validate address, which takes in a string of address, and we can pass our regular expression. We want our address to only contain digit and letter. So which means we take 0 to 9 character, A to Z, capital A to capital Z, plus underscore and the space, and those characters should be one or more. That's our regular expression, and then we need to branch with conditional. If our regular expression we want to full match the regex address, so which means if the address doesn't match this pattern, we need to raise the validation error, and we pass some message. Address should not contain special character. Okay, so now that we defined our function as a validator, we need to pass in the validator keywords from share imports validate address, and then we pass validates address. Okay, we want to also validate the second line, validates address. Okay, what about the phone? For the phone, we're gonna use the US phone number formats, which is something like 3 digits followed by 3 digit under brackets, or just 3 digit followed by, you know, another 3 digit, and then the last one 4 digits. We want to use this format. Let's make a phone number chart feed instead of making that a number, because we want to validate by applying business rule. Yeah, so max length, we say 14 character. Validators, we don't have any validators from now, but we want to make sure that it should not be null. Null should be false. Blank should be false as well. So now let's create our validator for the phone number. You can go back to the share file, validate phone, text the phone number. Okay, let's call this variable US local phone equal to anything which starts with parentheses, right? That contain 0 to 9 digits, and these digits should be at least 3, should be 3 digits, finishing by a closing brackets, or starting with 0 to 9, so between 0, 1, 2, 3, 4 to 9 must be 3 digits, ending with a dash, and the closing brackets, simple parentheses, followed by 0 to 9 digits, 3 digits, followed by any 3 digits, and any 4 digits. Any 4 digits as the last digit. So the following regular pattern will do something like a 000 a space 30 dash 3 dash 4 digits, right? So that'll be the pattern, you know. So anything 3 digits or something like 3 digits dash 3 digits dash 4 digits. That'll be the pattern we need to match. Okay, next, now we need to verify. If not, full match US local phone. We know that the phone number is a string, but we just need to stringify that again. Phone, if it doesn't match, we raise a validation error. Phone, let's say phone number should be of format 30-4 digits. Instead of using the formats, let's just make it address should not contain special character. And that's all for our phone validation. Now let's go back, import phone, validates phone. Okay, now we can validate our phone. Okay, so what about constraints? Let's create some constraints about our customer. Or before we create constraints, let's add one more thing, the citizenship, because we want to know where we want to get the citizenship of the person. Citizenship models char field. It's just gonna be max length of, let's say 50 character, null equal true, blank. No, we want to make a citizenship compulsory, null false. It should not be null, blank false as well. We're not gonna validate that, or we can also make sure that it doesn't contain special character. Validators equal to validate address. Since we don't have to name that validate address, let's correct this one. Let's change the name of validate address to something more generic. We call that validate special chars. So we need to import that here. Validate special chars. Validate special charts, which means we don't need special character in this citizenship string. And last but not least, ID number models char fields, max length 14, blank should be false. I like to start with null because null is what is apply on the database level, and blank what is apply on the form. Blank we leave this one to true, like as if it's optional. No, let's make that compulsory. Blank false, null false as well. Okay, constraints. Now we need to define a constraint for this table customer. The first constraint is the unique constraint, which means we need unique fields for ID. For any ID number should have only one citizenship, right? no ID number, and the citizenship must be repeatable. So we have a one ID number for one citizenship. That's the constraint, and let's name our constraints unique ID number citizenship. Okay, we also need to define the string, the string, so we can see every time we call or print the object customer. We're just gonna retain the first and last name. User gets full name. Okay, that's our customer physical model that will generate a table. Okay, let's do some migration now. Before we do, check the status. What do we have here? We have new files that we need to start tracking. Add git status. Okay, we got a bunch of them, including the previously modified middleware async that we've explained extensively. Go check out the video and see. I don't think anybody has explained middleware as we did in that series about Django middleware, but it is what it is. Okay, let's commit this. Git commit create customer model. Commit that. Let's migrate, make migrations, banking. Okay, banking app is no install app banking. Yeah, as a reminder, I'm talking about commercial banking here, which is a financial institution that sell money for money. I'm not talking about other bank, just to avoid the conflict of interest. Let's go on settings. So let's add banking as an app. Go back to banking model and continue. Make migration banking. Okay, we're making our migration. Okay, so we create our migration records. Let's check our init, which gonna create the table customer. We can add that. Banking migration 001. We add that status. Settings, we have a new change in setting as well. Let's add insurance settings. Git branch status. Okay, let's commit that. Before we commit, we just need to migrate that. Item manage migrate banking. Okay, we should have our table customer now with business rules and constraints. that's how you model your physical or entity. The physical entity should match business rules and business constraints. I'm not trying to knock somebody down here. I'm talking about data modeling. Therefore, I should give an emphasis on these concepts: business rules and business constraints. Okay. Now let's continue modeling. Next, we need to, can we verify if the customer, we have a table customer. To verify that, we go to admin, just to make it simple, from banking model, import customer, and admin sites register. We're gonna register customer. So we register the model customer to the default admin site. And to verify that, let's run the server, Python manage run server 8000 9001. Okay, let's go check it out. Local host 9001 admin. Do I have a username? Don't save that. Okay, now let's verify that the business rules and constraints should be applicable. If we create address line 1 with hashtag 123 main streets, and we tryna save, we see we got a bunch of error, validation error. Address should not contain special character. If we remove the special character and we save, we see the address line 1 is valid. Let's put address line 2, something like apartments 780, apartments 002. Let's try to save again. It's valid. How about we don't put anything for the address 2? It's still valid. The country is required. Country is United States. And you may be asking question why we cannot just select a bunch of country. Usually when we're creating an application like this, the country will be populated from the front end, and the front end will send that to the back end. The states, we say Texas. Phone number, okay, this is an interesting one. Let's try our phone number. Let's try 690 0001234, and let's try. Now we can see the phone number should be a format 0-0-0. If we just make some dash here between the last 4 digits and the previous 3 digits, and we save, we can see now the phone number is valid phone number. And citizenship, we can say American, the ID number 68, we can say something like 1 2 3 4 5 6 7 whatever, and let's save that. Now we can save. We can get the name of the user. Why? Because the user is now, the first name and the last name for the user is now defined. Okay, as soon as we update the first name and the last name of the user, as you can see, the user first name and last name, which is myself, we will see that the customer will display first name and last name. Now let's continue modeling our problem before we solve what is required. Now we need to model the account entity, create our physical model for the account, and still we are assuming that we are dealing with a commercial bank here, which is a financial institution that sell money to make money, but also accepting customer deposits of US notes or any foreign notes. Okay, class accounts, models, model. We need to create the account type equal. We should deal with account type should be of type of text char field, and this should be a choice between account type checking saving So we are creating a list of tuples from which we need to select our choice, and then if this choice is now one of the tuple sets, Django will throw a validation error. So account type, it should be account type, max length, let's say 9. You don't need the comma here. Next one, balance. As you know, in every commercial bank accounts we have a balance. So models, decimal fields, max digit. So the balance should have at least 11 digits, which include 2 positional digits. By 11 I'm guessing something like let's do this 1 2 3 4 1 2 3 7 1 2 3 10. Yeah, so the maximum the customer can have should be something like 99 million. Let's say 1 2 3 4 5 6 7 8 9 10 11, this is 100, this is million. So if we add 2 position, we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's make 13. Okay. So 13 digit including 2 positional digit. That will be the balance. And the balance will be for customer. Now we need to create foreign key to customer. Okay, there is another constraint. If there is a business rules that say that we should not delete an account when a customer, we should not delete an account within the first 3 years when a customer decide to close an account, right? So in that case, as soon as someone leaves or a customer leaves, there is no customer X. We don't want to delete automatically the accounts. We need to keep the accounts maybe for, therefore on delete we need to protect that. We can say on delete we just set that to null, right? Let's protect that. Yeah. So which means before we delete the account, this account, we have to delete the customer. Related names, let's make the accounts. So this one represents accounts, right, to each customer. So customer dot accounts will retain all accounts. That's for our customer. Next one, created on when this account is created, daytime, auto now add true, which means as soon as we create these accounts, Django will insert the daytime of the account creation. Last update, there is another provision that Django has created for us. Last update, when was the last time this account has been modified? Auto now to true. Created on will be once, and the last update will be every time something change on this table. Okay, next let's talk about the constraints. Okay, what is the constraints on these accounts? We're gonna create a constraints array and define a new constraints model, unique constraints on fields. Okay, account type should have one account number and one customer. So this constraint, this unique constraints of, what we're writing here means that for each customer, and their respective account type, there should be only one account number. So no customer should have two account number with the same type. That's the meaning of this constraint, and this should be a business constraint. Okay. Name of this constraint, unique, and the name of the constraint is the name that will be applied in the database level when we create constraints in Postgres or MySQL. Account type, number, customer. That's the way we need to name it, so we can know what are we dealing for. We're dealing unique, account type, number, and customer. That's the constraints. What about the string we will need to return when we create our accounts? Let's get the balance. We need to stringify self balance. Okay, and then we will return three two. We are just formatting the string 0 and 1. So what are we saying here? So what we're saying here, we need the balance, from the first character after we stringify them. The balance should be I think a float or a decimal. The balance is a decimal, so we get from the beginning to the third character, and we also get balance from the third character to the last one, and then we get the account type. And we also get I think the account number and the account type. This should be balanced. Okay, that will be the name of the account when we create the notation. Accounts number. We don't have account number. Oh, we need account number. Accounts number. See, we need account number. Let's make account number HR with a maximum length of 10 digits. Null should be false. Blank should be false as well. But we need the accounts to be digits. Need to be a digit that I have at least 10 character. To do that, we need to create a validation. Validators, passive validator, keyword arguments, and define our validator in the share file. Okay, so let's define validate account number, validate account number, we get the account number, which will be a string. So if not account, let's stringify that, account is digit and length account equal to 10, we raise validator. We raise a validation error. Account should be 10 digits maximum. Account should be 10 digits maximum. Okay. Now we need to apply a validation on the model. Let's import validation. Okay, validate account number. What is the account number? Okay, we validate the account numbers. Okay, that will be the accounts. Now let's model the campaign. As we know, we want to add 0.25% to each newly created accounts, which deposit the minimum of 1,500. If the balance is 15 or is greater or equal to 1,500, we need to add that customer 2% to their current balance. That was the requirements, and before the requirements can be applicable, we are modeling each entity. We've modeled the customer, we model the accounts now. Now we need to model a campaign, because from the campaign, we're gonna create a campaign where we are giving a certain percentage, and when the campaign is done, we stop giving that bonus to the newly created customer. Okay, so we have the campaign model. Okay, from model. No, this is now a function. It should be a class. What am I talking about? Okay, let's create a campaign. Campaign type, model char field, max length 10. Our choice, we have a two type of campaign. One campaign is the welcome campaign. We name that welcome, where trying to welcome the new customer with some bonus. Welcome. And the other one is a referral campaign. If someone refer a customer and they do have an account with them, they will give them some percentage. Okay, so campaign, and this is just an example just to demonstrate what we are trying to accomplish here. Campaign Yeah, campaign type. That should be campaign type. The starting date of the campaign should be a model date field. The end dates of the campaign should be model dates field. The bonus, what should be given to them, and the bonus, it depends of again the business logic. If we want the bonus to be a number, which means $1, something like a $200, we can just create that as a number. But if you want the bonus to be a percentage, since we are giving a percentage to welcome new customer, we can just create a decimal field, max digits 6, and decimal place 4. Let's see our bonus, our balance. Yeah, this one will be, the decimal place will be 4. So what are we expecting? We're expecting something like a 0.025. 1, 2, 3, 4, 5. Right. Okay, 4 place 1, 2, 3, 4. So if we do something like this, yeah, that's the way it's gonna be. But if we do 10%, it's gonna be 1, 2, 3, 4. Right, so we want to give 2.5% to each newly created customer. So that's the one we're gonna use, that the format 0.02.5. Okay, that'll be the bonus. And let's apply with the class meta some constraints as well. The constraints for the campaign, still we're gonna use a unique constraint, models, unique constraints, fields, the start dates and the end dates should be unique to each campaign. No campaign should have starts and end dates that's similar. What is the name of our constraint? Unique starts and end dates. Okay, we got, I need the comma there. Okay, that's our constraint. We also need to create some indexes. We are on the physical models, so on the physical model we need to create indexes if possible. The indexes allow speed reading. Remember, if your table is more a readable table than a write and read table, you need more indexes. If your table is only is more a readable table, which means your table gets more traffic on the writing records than reading, you don't need too much index because it's gonna slow down. It's gonna decrease performance of your table. If you didn't know, now you know. Okay, since in the context of growth mindset, we're gonna index this with the start dates. By default, every primary key is a default index key. So when we create another index start date, it's gonna add the ID index. But to make it clear, we can just do ID and start dates, right? And also ordering, we need to order the table by start dates descendants, not ascendants, from the latest start dates to the previous start dates. That's our campaign. Okay, for this video, and the purpose of this video is just to give an emphasis on data modeling, and I know it's getting long. I will stop here. On the next video, I'll demonstrate how we can create this record by also using Django signal to automatically increment the 2% on a newly created accounts for this application, so that the problem which states that we need to add 5% to all newly created customer who deposits at least 1,500 between dates X to dates Y, right? That's a small problem, but we use this problem to demonstrate why data modeling is so important. You shouldn't be start your application, without modeling data. And I know it's not, it's a recursive, if not an iterative process where you will still tweak a little bit on your data, but data modeling, whether you are using agile development process or you are using any lean development process, which is a child of agile, still you need to model your data before creating your tables.